Alright, I will tell you something about how you can make a web application from R. Maybe some of you have seen my website, in which I have created a few of the interactive web applications. If not, I will quickly demonstrate some in a minute. Alright, so the first, maybe you've seen some web applications. If not, I will show them to you. What I do basically with web applications is I use R on the server, and on the client side I use JavaScript to create an interactive graphical interface for an R package, for an R function. Well, you could ask yourself why would anyone want to do that. I think R and JavaScript they are a very good combination. They are a match made in heaven, maybe even. What's so special about combining to do? Why would you want to? I think R and JavaScript they have a lot in common. Both are they're very loose, accessible scripting languages. They are easy to start with. I think for both languages, most people they start using it without ever reading about it or ever opening a book about it. It's something R is like calculator. You can just start using it, and JavaScript is like if you have to create a web page and then you see some example JavaScript and you read that, you think, well, I can do that. Both languages they have huge and quickly growing communities that are like for R I think there are about a million users, and for JavaScript maybe a billion users. Both have lots of libraries and packages available. I think that's like the biggest commonality. Both R and JavaScript, they are not really the most elegant or the most powerful languages. But the actual power of the language, it's provided by the fact that there is so much available. There's so much that's already being done for you. R has like thousands of packages with all kind of algorithms and calculation stuff. And JavaScript has even more libraries and packages for that you can use to create like interactive, graphical, fancy stuff with only a few lines of code. So yeah, in that respect, they are very similar. Both have become standards in their field, more or less by accident, I think. And both communities seem to have a problem with Java. It always creates a bug. But they also, like in a good relationship, they also complement each other. R is very powerful. It interfaces C, Fortran. You can access databases, LaTeX. There are many computational packages available. You can do all kind of heavy stuff with R. And JavaScript has a completely different purpose. It's very nice to the user. It's made for creating beautiful things. You can interface to the DOM, to CSS. Yeah, it's actually the perfect language for creating next generation fancy stuff. So yeah, what I've experienced when I started doing this about a year ago is that you can, if you put R and JavaScript together, you can create very cool stuff, but in very little time, even though you're not a particularly talented web developer or statistician. So that's maybe a relief. Yeah, so what is a web application? I created some, but I will just give a quick demo to show you what's possible. Maybe some of you have seen this already. So the one that I will show here is called ggplot. It's a web interface for the CRM package ggplot by Andy Wickham. And you can, with the package, you can create nice fancy graphics using the R syntax. And this is a graphical interface for that you can use to do this interactively. So you can just go to this page. Well, I don't have internet here, but it's just publicly on the internet if you follow the URL. So the first thing you do is you upload some data. So for example, I have some example data here about movies. It's just a comma-separated file. There's nothing special about that. Once you have uploaded your data to the server, here appears a list of your variables that are in the data set. So they are split in the type, whether they are a vector or numeric. And ggplot, if you ever use it, it uses graphical layers. So you create a graph, a plot, by stacking layers on top of each other. So that's what I will demonstrate here. The layers, the graphical layers will appear here. Here will appear the properties of every layer, and there in this box, general properties of the graph will appear. And in the bottom, there's a tiny arrow, and if you open that, in the bottom, there's a syntax window now, and this is like the R code that's actually executed once I start creating the graph. So it's meant to be, the tool is meant to be, you can use it like this, but it's also like an education tool or if you would publish a graph, you should also publish the syntax that you can use to reproduce the graph using the data. So once you uploaded the data, you can map the variables. For example, this is data about movies. So I can, for example, I would like to see if the budget of a movie is a predictor of the rating of the movie, and the rating is the IMDb rating. So I map X to the budget, I map Y to the rating, and if I draw a plot, then you see that the axes they are mapped. The X axis is the budget, the Y is the rating, but nothing is visible there, because you have to manually add the graphical layers on top of that. So for example, if I want to add a point layer simply a point for every data point. So if I add the point layer, then it appears in the layer list, and if I redraw the plot, there's a point for every point in the database. And then, for example, I can add a new layer, for example, a smooth layer. And that creates, on top of the point layer, it creates another layer with a smoothing line. So it tries to estimate a relation between those two. And then I can, for example, once you added a layer, they appear here in the list, and now you can change properties of the layer. For example, I want to set a method to a linear model. And then it's a straight line. And now, for example, if I would like to see if this relationship holds for different categories of movies, one of the variables in the dataset was the MPAA rating, which is, I was told, something like how dirty the movie is. So, for example, you can map the grouping to the MPAA, and you can also map the color to the MPAA. So what this will do, it's because you map the color and the grouping of the graph to the MPA, there's for every MPA category there's a different color assigned, and also the smoothing inherits that grouping. So there's a different model estimate for within every subgroup. And so, for example, you can also map the facet to the MPAA, and that will create, instead of that they're all in the same plot, faceting means you create several plots next to each other. So now there's a different graph for every grouping, and then you can see that the relationship between the budget and the rating is more or less similar for all categories except for this one, but there's very little data about this one. And it's interactive in the sense that here are the layers, so once you click the layer you see the properties of this layer. And here are some of the general properties. And here is the syntax. So if you copy paste this syntax into R, including this line where you import the data, you get exactly this graph. And of course there are options to export this to PDF, so you can store it somewhere. So
you are serving this application off your website or using
yeah.
servers? if you want to try it, it's publicly available. UCLA has been so kind to sponsor a server, so you can wait. How do I get out of here? So you can just visit my website, or you can go to this URL jeroen.net/ggplot2, and then you can try it. You can just upload your own data and play around with it, and please don't break it.
Can you show us a little bit about how the JavaScript is calling R?
I will. I have a slide too. The next couple of slides will be about that. First, you get excited about that. All right. So, short summary: what is a web application? What are the kind of web applications that I want to show you? I make a web interface for a simple R application in which R runs on the server and the user only needs a standard web browser. So JavaScript runs in the web browser. The only programming that I try to use is R and JavaScript with HTML. I try to avoid other languages like Java or PHP ones. PHP. It's not necessary. I use Ajax interfaces to make things interactive, that you don't have to reload the entire page for every little change you make. What it's not about, my applications, they are simple applications. So I don't have any advanced queuing systems for running multiple simultaneous R jobs, or if you want to do really heavy stuff, that's not really the setup that this setting is appropriate. I don't use distributed computing yet, and I don't use Java. So why would you want to make something like this? Well, it's convenient. You can make, if you have something nice, you can make it quickly available to a wide audience. For example, I had a little publication with Professor Stefan Buren, and he created a new type of diagnostic diagram to detect developmental problems in children, and he created a very nice R function to plot that using data. And it's really useful, but of course you're never going to get a physician to install R on his computer. So we created a website in which they can just fill in the data for the child and then press plot and then get the plot. And it's really successful. People are using that in hospitals right now. So it's an easy way to make things accessible. So the user only needs a web browser. It's cross-platform. I think that's a big advantage. And these days, more and more people are using Linux and OS X, and you don't have to worry about whether it's compiled on every system. Its web applications are server-based by design, so they make more efficient use of resources. In the old days, everyone at the faculty, at the department, needed its own fast computer to do its analysis. And you can imagine, in the near future, there's just one server and everyone just accesses that from his web browser and stores his data on that, and then all the analysis are done on that. And you just need one big machine that's much cheaper and more efficient than all the different machines.
Back to the past.
The past and the future. They're easy to maintain. So if you want to do some upgrades of your application, you just change you don't have to send CD-ROMs to all your clients. And it's easy to integrate with existing services and databases and stuff like that. And the last reason why would you want to make web applications, because you have to. More and more services, they are only available from the web browser. People more or less expect, if you create something new that doesn't really require any local heavy stuff, that they can just do it from the internet and just many people, they can't or don't want to install software anymore on their computer. So that's another reason to switch to web interfaces. All right. Now it's your turn. I'll try to show in 5 or 10 minutes a little hello world of the basic setup of how you would like to create something like that. So I have a web server that's here. This is the root of my web server. So for example, if I create a new file in my web server and I call it
hello world. So this is the file that I'm editing here, and it's now available from the browser. So if I add something here, and I reload it here, it becomes available here. So it's just on this web server, I installed a special package. It's called Apache. The reference is at the end of the slide, and that allows you to embed our code within your web page. So what you do is you add these magical tags, and you have to add print. So now if I reload the web page, I'll get the output of the function instead of the syntax. And you see it's pretty fast. I press F5 a few times. I can reload it, and it's usually when you load an R session, it takes about 2 or 3 seconds before it starts up. Things loading and stuff. The Apache, it has very good caching mechanisms. It's extremely fast. It responds in less than a few milliseconds. So that's very convenient.
Is Apache an R package, or is it essentially?
It's an Apache module.
It's an Apache module.
Yeah. Right. So this could be like a random number generator, but for example, you would like to post arguments to make it more customizable. So, for example, what you could do is you could make a little form. So this creates an HTML form in which I can add some elements, like I can add some input fields. By the way, if you have any questions, please interrupt me.
So at this stage, if we use a plot function, is that going to show up?
I'm sorry?
If we use a plot function, like plot density R norm,
Yeah.
100, is that graph going to show up in
That requires some extra work. What I show now is just how to post data to a server and then get something back. So what I do here is I create several input fields in which the user can insert some data. And these input fields, of course, I will connect to the rnorm function. And here I make a final input field, which is a button, a submit button. So that creates a simple HTML form. You might have seen that already. So, and because it's outside of the measurable tags, it won't be interpreted as R code. It just return the way it is.
You have to close the form.
Oh, thanks. And so in your R code, you can because these values that the user inserts, they are posted to the server. You can extract them from the server. They are stored in a variable called post,
because I use a method post.
So for example, here I extract the variables from the post.
If I make a typo, please tell me, okay? Then it won't work anymore. I'll make a fool of myself.
Alright, so what you see here is the form, and this is the output of the R thing. So for example, I want 100 random numbers with a mean of 10 and a standard deviation of 10. Then
they are returned to the browser.
They're kind of ugly right now, so I'll wrap some tags around it to make them more pretty.
Yeah, so this is like your Hello World, your first random number generator.
The user can put in any type of number, and then
how gracefully does it fail if you put in like text up there, like a instead of a numeric?
that's the next step.
I wasn't saying how you validate it, but how gracefully does it fail? Is it
Yeah, I will show that. In exactly now. So this is your random number generator. It takes arguments from the form, and then in R in the server it parses it and then feeds the output back to the user. Now, for example, let's do something impossible. So I fill in here a minus. So minus 10. And then you get a server error.
So it doesn't fail. It doesn't fail gracefully.
So what I usually do, what I recommend people to do, is that in your R code,
This is like the actual stuff.
that, by the way, can we see this in the back? I wrap this into a function. For example, I call this my random function. And then I can create another function, and I call this function print error. And what this function does is it prints the error message. And then, like the actual code that is called is a try catch of the random function, and then an error, it sends the error to the print error function.
Yes. Alright, so this is
So what happens is the actual first these two functions are read in the memory. Then it tries to call the random function. When there's an error, usually it just stops.
like what you just saw. It returns a server error, a internal server error. But using a try catch block, you can catch that error like try catch like you would do it in Java, and then instead of stopping, you catch that error and you do something with that error.
So in this case, we print an error. Maybe we can print something else.
Is try catch a function that's standard in R?
Yeah, try catch is a function that's standard in R. So if you go back to the function, if you insert something normal, it still works. And if we insert a negative number here, we get our outputs from. And of course, you can do more stuff with this, but this is just the basic. That it's very useful in general that the user can see what's going wrong on the server and something's going wrong, especially if you have like applications where you can upload data. there's a lot that can go wrong when data is imported, and then if the user can get to see the error, that can be extremely useful. The user can like get a feeling of what's going wrong. All right. So this is the practical stuff. Now some more theoretical stuff, like the general concepts about if you want to make something that's a little more advanced than what we just saw, that has more functions. There are basically 4 steps in creating a web application. There's the interface. There's the user that interacts with the computer. That's the interface. It can be a graphical interface. In our case, it doesn't have to be. Then from the interface, there goes a request to the server. The format of the request is something that you want to think about. How should you format this? The server then calls R. It does whatever it's supposed to do. It executes functions, it draws a plot, whatever. And then there's a response that goes back to the interface, and then the interface is updated, and then the server is run. So, for example, if you would apply that to the ggplot application that I demonstrated in the beginning, the interface is the graphical web page with the menu, the buttons, the layer list, etc. And that allows the user to configure a plot, and the plot is just stored in the memory of the browser. Then a request is when the user presses the draw button. A request is sent to the server, and the request contains the configuration of the plot that has to be drawn. So it contains the settings, the mappings, and the layers and stuff like that. The server decodes this configuration of the plot, and it draws the requested figure, because that's the service. And then the response is the plot figure. And then from this response, the interface updates the figure within the page and makes the appropriate changes in the user interface. And then the user can continue the process. So, the most important part of this, I think, like, what the interface look like, well, this is JavaScript. This is extensively covered in the manual, so I won't tell you a lot about that. And well, this is just the R code that extracts the arguments and then does whatever it's supposed to do, so that kind of makes sense. What's the core of web application is kind of the protocol, how these requests and responses are formatted, what exactly is communicated between the browser and the server. So the message specification, that's how I call it. So the big question is, how do I get my objects from the client browsers onto the R server? So in the ggplot application, I was creating this configuration of the plot in the browser, and then at some moment I want to send that entire object to the server, and then so how do I do that? HTTP protocol basically only creates strings for arguments, so you need to find a way to wrap everything that you have, the entire object into a string, and then send it to the server. So yeah, that's what I thought. You maintain a request object in the browser. You define a way to encode that into a JavaScript object, and this is what you add to the, for example, the post that we saw in the example. And then on the server you decode that, and the same is done for the response. So how could this communication take place? If you make an advanced web application, it's probably smart to use some kind of standard language to communicate between the browser and the server. There are two standards for data communication. They are XML and JavaScript object notation. Both are very well implemented in the browser in all kind of packages for JavaScript to parse XML and JavaScript object notation. And for R, there are the packages XML and RJSON that's on the server side can encode and decode your these data formats. So that's very convenient. So basically, whatever you do is you have an object, you encode it on the client, you send it over, and you decode it on the server, and that takes very little effort. Which one should you choose? XML is most widely used. It's the big standard. So if you want to create an R application that should be integrated with existing services or in some big company, then probably XML, they want to have it in XML. JavaScript object notation is much lighter. It's it's only a few. It's recently. It's more new, and it supports arrays, and it's preferred for large data sets. And I will show you why. But this is, for example, a very simple example of what an XML object could look like. So you probably have seen this. XML is you have the opening text and the closing text. And let me show it because you can have attributes between that, and then every value, every primitive value has to be close between two of these tags, and they are like in a recursive tree. And if you have a similar model in JSON, you would use this. JSON uses curly braces to define an object, in which an object is a list of key value pairs. It divides the square braces to define an array, which is just a list of values. And the colon is used to, you have like, this is the key, and then every key is followed by a value. So, well, if you see it kind of makes sense. Everything between the curly braces is like a list of key value pairs. And if you have square braces, you don't need the keys, you only have the values, so only objects. And then a value can be a primitive value, it can be an array, or it can be another object. So that works recursively, of course. Yeah, and JavaScript is loosely typed. So in many languages, an array has to be an array of the same objects. But JavaScript is loosely typed, so there's no object type, so you can just throw in everything you want in a big array. And the big advantage of using JavaScript object notation is illustrated here. If you have like a lot of data, you can, for example, you have this is a little data set of several records. Then it's very easy to put it into an array with a key value. If you want to do this in XML, you have a lot of overhead because every value has to be opened and closed with new tags. Yeah. So how does this work in the application? Basically, I only use 3 R scripts in the ggplot web application that I demonstrated in the beginning. The first R script that I do is called ggplot upload. Basically, what it does is when it's called, it starts a new R session. It reads in the data file from that's posted to the server. It imports the data file into a data frame in R. It saves the session, and then it returns the information about the data to the user, and it returns the session ID to the user. And then the user gets that back, and he starts playing with this plot. And then when he draws plot, ggplot png is being called, and what this does, it decodes the plot configuration and the session ID from the post variable. It loads the appropriate R session that was saved before, and it draws the plot, and then it returns a link to the figure that was just created. And the PDF does exactly the same with the PDF.
So does R support multiple sessions natively, or does it load a different instance for R for each? Is it a separate process that it loads?
Yes, every call is a new R session is created. So well, I'll return to that later. But the configuration I use is that every time R is called, a new session is started. And the reason why I do that is because there's practically no overhead, as I showed you in the beginning. An R session, if you set it up on a Linux box with R Apache, it takes about 3 milliseconds to create a new R session. So there's not a big advantage of keeping it open on the server.
Once you upload like a big data set, you can do that in the
Yes. So, but even that it's actually pretty fast especially if you start to integrate database and stuff. But yeah, a difference is possible, of course. So some very simple JavaScript, just to, as I already told you, I'm not planning to giving you a course in JavaScript because that's being covered everywhere on the web. But to get some idea of how simple it is, I use some libraries. So these are not default JavaScript functions, but the libraries are all open source and freely available. And basically, this is like the function that's called when you press the draw button on the web application. So what it does, it finds the appropriate elements of the web page, and it calls the load function of this web page. It integrates the configuration, so it shows like the timeout, the URL. So of course that has to match the name of the script that I just demonstrated. So ggplot.png. The method is post. The parameters, so that's like the what's added to the post variable. It's as simple as this. I retain an object in the cache of the browser which is called plot_config, and then I use a library to convert that to JSON. So it's as simple as that. And then the callback, in callback you can define what should happen when the request returns. So when the server returns with the data or with an error, which also can occur. So in an example of the ggplot2 application, what does the request look like? It's more or less what you would expect it to look like. It's a list of the things, the information that is required for the server to know what it should draw. So it shows all the mappings, the facets, the layers, and the data file and the size of the PNG that's in the browser. And a small fragment of R code on the server, just to give you some idea. What it does, it uses from JSON, so the other way around. It takes the big JSON string. It's the from JSON converts that back into an R object, so a list with all kinds of things. It extracts the session ID. It then loads the session ID, so you get the appropriate data file is loaded into the memory. Then it decodes the configuration of the plot. It creates a random name, a random file name. Then it opens the PNG device. The plot is being drawn to the random file name, and then what's returned is the name of that random file name to the user. So the browser knows where to download the image that was just created using the script. Is this clear, more or less? All right. Well, that was kind of my my general introduction and the example of ggplot. Some last things that I want to send you home with when you want to start doing this yourself. Use Firefox and the web development toolbar and Firebug for development. I'll quickly show you why. So this is, for example, Firebug. Here I can enable it. Not sure whether it works, I just updated it. Yeah, so what's here, you can see like there's a list of all the invisible requests that are going on. It's really low again, right? It's on the bottom of the screen. Maybe I can make it louder. So for example, if I create a plot here, then here in the bottom, you can like spy on what's really happening. So it's really small, but you can like all the AJAX requests, all the HTTP requests that are going on that you don't see, you can see what's going on. So that's really useful if you're developing something. So for example, here you can see what the post looks like. So you can indeed verify that that what was posted to the server is indeed a list of all the properties that were used to for the plot, and then what was returned, the response, is some HTML code with the appropriate image. Yeah. So what else would you like to do? Design a protocol that makes sense semantically. when you start doing this, it's really attempting to use R to create HTML code, or there are like packages like R2HTML, and with that you can create like a nice HTML table, so you don't have to worry about that, and then you send it back to the server, or to the client, and then you can just plug it into his website, and then you have an HTML table. But that soon becomes really unmanageable, because when you want to change something on the server or on the client, you have to go like change that in the server side. And for example, if you want to add some interactions to the table, or you want to do some different layout, you can't just do that on the web page. On the web page, you have to like go into the server. So you don't want to go there. What I recommend is to keep your protocol purely semantic. Only send information over the line that's absolutely required. So think about it on beforehand, like what does the server need to know to plot what's supposed to plot, and nothing else. And then what's returned is also only return data that's absolutely necessary for the client. And then all the layout stuff can be done in the client. You don't have to do it in the server. So back to your question, there are different ways to connect your HTTP daemon to R. What I just showed you is Apache. So the setup of this is it creates a new session, a new R session for every HTTP request. It's very fast. It's got good caching, so I prefer that. But an alternative is you can just call R script directly for PHP or CGI. So you don't need any. Don't need to install any modules or something like that. So, and it works on Windows. The problem with that is it's a lot less fast, it's a lot slower, and it's actually sensitive to code injection, which I will say something about in the next slide. A completely different setup is created by using rserve. Rserve is like a daemon. It's an R server, so it opens a session, and that session keeps open the entire time, and the users can connect to that, and this disconnects to that, but the session keeps open the entire time. So the R session is kept alive. So if you want to create a web application in which it makes sense that you have that the session is kept alive, and that you can reconnect and disconnect to that, you can use rserve. But it's a lot more complicated, and it requires an additional rserve client, which is not an R package. And a big disadvantage with what I have experienced is once in a while things go wrong. And if you have a new R session for every request, when something goes wrong, it's not a problem. The user gets to see an error, or maybe even worse, and he doesn't get to see anything, but there's no really enduring problem. When something goes wrong, if you have like only one R session that's open the entire time, and one user manages to screw that up, then your entire system is down, or you need to perform additional checks for that. But it's more fragile, that setup. So that's a disadvantage. But of course, you can also go that way. Well, what I would show, try to catch errors and give them back to the user. Once in a while, a user tries to do something that's really impossible, and that would take 3 years to calculate. So what I always do is, at the beginning of every R script on the server, I set a time limit. In this case, for example, 40 seconds. And in the end of the script, I reset that time limit. And what this does is, the R session is started, the time limit is set, and then when the R script finishes before that time, there's no problem. But when 40 seconds have elapsed and the session is still not finished, then the user just gets an error that things took too long, and then it's killed. Because you don't want a few users to be consuming your entire resource of your machine for too long. And something about images. If you want to create graphical replication with images, there are several things you have to think about. First of all, what format do you want to be in? So PNG, for example, is a bitmap file. So the support for that is very good. It's supported in every browser. The problem with that is it has a static size. So well, what I do is in my web applications, I set the size of the window in which the plot is to appear to the server, so the PNG is created in exactly that size. The problem with that is when the user resizes the window after the plot has already been displayed, it doesn't fit anymore. Alternatives are to use SVG. SVG is, well, vector-based, maybe you've heard about this. It's defining images using XML, which is the future, but the browser support is not currently very good. And in R, it works usually, but not always. You can also use PDF. I like to add something to export PDF. People like that. PDF is convenient to save. It's vector-based, but PDF is not convenient to just show in the browser because you need to load the PDF reader. And you can also try Flash. There are some libraries to convert PostScript to Flash. Adobe claims that Flash is installed on 99.9% of the web browsers. So that's nice. If you want to go there. One thing, the file size. If you have a bitmap, the size of a picture depends on the size of the picture. So the file size depends on the height and the width of the picture. So no matter how many data is in the picture, it's just the size is that big. If you have a vector-based image, the size of the file depends on the amount of information that's in the picture. So, for example, if a user decides to upload a 10 MB data file and then create a picture with that, with points and lines all over the place for every data point, then if you want to return this into a SVG or PDF, these files will become huge because for every data point there's actually additional information in this file. So, well, beware of that. And some note about security. I'm not an expert in this, but watch out for code injection. What's always smart to do is the first thing, when an argument comes in, remove any characters that are not supposed to be in the argument. So any braces or spaces or command signs. That because well, people might try to find out what happens if they try to escape a piece of an argument and then add some code after that or something like that. And you don't want users to be able to run arbitrary code on your server. Because R, of course, it can interact with the entire system, so they can do whatever they want. And then last slide about graphical interfaces. If you want to make things fancy, please don't start a course in web design. Just use one of the frameworks, of the libraries that is available. Most of them are open source. They are developed with by many users. You can use them for free. My favorite one is X. I'll quickly give it them show you what it looks like. X is one of the biggest libraries out there. X, they claim that they have over 1 million developers who are maintaining everything, which is very convenient because web development can really be a pain because there are web standards, but not everyone follows web standards. And then if you create something, especially graphical, then it displays nice in one browser, but displays slightly different in the other browser, and you don't want to be taking all the time whether all your stuff works in all 20 web browsers and all the operating systems. So if you use just the library, you can be pretty sure that there's a big community testing whether everything works nice. And for example, well, as I told you, X is my favorite one, and it has everything for you. So if you want to create like graphs or windows, or you probably want to create grids when you're a statistician, you can create very fancy stuff with only a few lines of code. Let me see. Yeah, so it all looks very fancy, and you will probably recognize the design from my web application. And this is really it's really easy. It's a few lines of code and it does everything for you. It looks nice, and there are like modules in the library to that you can maintain little local databases in your web browser, and
store the data in a convenient way and access it. So that takes away a lot of work for you. That was more or less what I had to say. Here are the references. This is my picture. You can get the slides from my website. And yeah, if you want to like, if you need some help with your web application or you have some good ideas about what might be very useful to create, drop me an email and we can do something. Thanks.
Thank you very much. Any questions?